In this tutorial, we will be discussing the classifications of matter. Matter can be broken into different classifications. Two primary differences of pure substances and mixtures, and then those can be then broken down even further. And that's what we'll be discussing in this tutorial. A pure substance is composed only of one type of atom or molecule, where a mixture is composed of two or more different types of atoms or molecules combined in variable proportions. Let's start over here with the pure substances, specifically the elements. An element is a pure substance that cannot be broken into simpler substances. No chemical transformation can decompose an element into simpler substances. And all known elements are listed on the periodic table. Helium is a pure substance composed only of a type of atom, helium atoms. So let's compare and contrast elements and atoms real quickly. Think of them as Legos. If you think of Legos or blocks in general, and you divide them up by color, so you have some red blocks here, you have some yellow ones here, and you group them together. Okay, so you have all the red blocks together, all the green blocks together, and all the yellow blocks together. You can then break those apart even more by saying you have ones with 6 bumps. You have some with 8 bumps. You have some with 4 bumps, but they're all red. Okay, so the atoms are the individual Legos that make up the set of all the reds, which would be the element. And so on with the green. The green as a collective is another element, and the individual blocks within all the green blocks would be the atoms, or the isotopes of the atoms. Let's move on to compounds. A compound is a pure substance composed of 2 or more elements in fixed definite proportions. Compounds are more common than pure elements because most elements are chemically reactive and combine with other elements to form compounds. Water, table salt, and sugar are all examples of compounds. And compounds can be decomposed into simpler substances. Elements cannot decompose, and they're on the list of the periodic table, whereas compounds can decompose because they're made of multiple elements. So water is an example of a compound. It has 2 elements. It has 2 hydrogens and 1 oxygen in one molecule of water. They're in definite proportions. It's always a 2-to-1 ratio. 2 hydrogens to 1 oxygen every single time. That's a molecule. When matter contains 2 types of atoms, it may be a pure substance or a mixture. A pure substance would be the compound, the one we just discussed with water. Definite proportions always, for instance, with water specifically, it's always going to be a 2-to-1 ratio. So a compound is a pure substance composed of different atoms that are chemically bonded together, chemically united, in fixed definite proportions. A mixture is composed of different substances that are not chemically united, but simply mixed together. So we've used the word mixture a couple times now, so let's talk about mixtures. Air and seawater are examples of mixtures. There are 2 or more things that are mixed together that are combined, but they're not chemically bound to one another. So air is primarily nitrogen and oxygen. Seawater is primarily salt and water. So if we look at our flow chart, we see that the elements in compounds are pure substances and mixtures are homogeneous and heterogeneous. So let's look at homogeneous versus heterogeneous. Homogeneous is something like a sweetened tea, like if you put sweet and low in iced tea and just tea, no ice in it, just tea. that sweet and low is going to go everywhere in the container. It won't just sit in one particular area. When things are mixed throughout and is even throughout, that's the homogeneous mixture. When things separate, note the word separate. When things separate out, when things are not mixed evenly, that's when you have a heterogeneous mixture. Also, you might see the word solution. Solution is another word for homogeneous mixture. So if you see the word solution, you automatically have a homogeneous solution, homogeneous mixture, no matter what. Everything else you kind of have to analyze and ask yourself, does it look the same everywhere you look at it? And does it separate over time? And we'll do some examples of that at the very end of the tutorial. Alright, so summary. Matter can be pure or a mixture. If it's a pure substance, it can be divided up into element or a compound. Compounds are elements that are chemically bonded together. Mixtures can be broken up into homogeneous or heterogeneous. Mixtures may be composed of two or more elements or two or more compounds or a combination of both. Alright, so let's do some practice ones. Table salt, that's NaCl. Sodium chloride, that's a compound. You have two elements there that are chemically bonded together. Sugar, that is another compound. You have three elements there that are bonded together. Sour cream is tricky. Think about sour cream. Think about what happens if you leave it in the refrigerator. Eventually, the water drifts up to the top. Therefore, it separates out over time. Because of that, it's going to be heterogeneous. Salt water. If you make yourself some salt water to gargle or something, the first taste of salt water and the last one are going to taste the same. Therefore, it's homogeneous. Soil. Visualize soil. When you visualize soil, you realize that not every piece of soil looks exactly the same. You have different compounds there. And if you look at soil in one location and take from the same yard a different location, you're going to have two different samples that are similar, but they're not exactly the same. Because they're not exactly the same, it's hetero. Oxygen. You can find oxygen right on the periodic table. It is an element. It cannot be broken down any further. Carbon dioxide. You have carbon and two oxygens here. Therefore, you have a compound because you have carbon and oxygen that are chemically bonded together. Peanut butter. Once again, think about peanut butter. Specifically, think about natural peanut butter because the name brand ones, like Jif and things like that, put emulsifiers in there to keep it in solution. But if you think of natural peanut butter, eventually the oil rises up to the top. It separates out over time. That's what you have to ask yourself. Does it separate out? And if the answer is yes, it's heterogeneous. Iced tea. Once again, visualize it. You'll have the glass of tea, and if you put ice in it, the ice is going to rise to the top. So that means the iced tea at the top is going to be more dilute than the iced tea on the bottom. Therefore, it's hetero. Hot tea. Hot tea, however, is exactly the same throughout because there is no ice in there floating on the top. Vegetable soup. You look at it in one location and it might have a green bean. Look at another location and it might have a piece of corn. It's not going to be the same everywhere you look at it. Finally, diamond. This is a trick question. I threw this one in there just to try to trick you. A diamond is actually pure carbon. It's a special kind of pure carbon, but it is still indeed pure carbon. Because of the fact that it's pure carbon, it's an element, because you can find carbon on the periodic table. And that is your explanation of classification of matter.